this assessment asks us whether radical iodination would be selective for forming the radical of propane in the first propagation step. So as a reminder, the iodine radical is going to abstract either the secondary or the primary hydrogen. To determine whether this is going to be selective or not, what we're really asking is it an endothermic or exothermic step? I've gone ahead and identified the secondary CH bond is 95 kilocalories per mole. You can find that in the chart over here on the right. The HI bond that forms is going to be worth 71 kilocalories per mole. That's in the chart up here in the upper right. And then the other one that matters is the primary CH, not shown on screen, but in the table in the text, is at 98 kilocalories per mole. And so we can simply do the calculation where we subtract the bonds formed from the bonds that are broken. And that's going to give us, for the first step, a delta H of plus 24 kilocalories per mole. So formation of the secondary radical is endothermic by 24 kilocalories per mole. Do the same thing for forming the primary radical, 98 minus 71. Delta H, for this case, is going to be plus 27 kilocalories per mole. So still uphill, but slightly more uphill. Given the fact that both of these reactions are endothermic, this reaction should be selective, as it will have a product-like transition state.